Everyone, in this video we're going to go through the solutions to the 2024 data sack, just part one. So this sack relates to this data, so I will be flicking back and forth to the data page. All right, so that's the front page. Let's have a look at these questions. So actually, let's look at the data first. So we're looking at a survey that was conducted on participants, and we collected the following information. So eye color, gender, age, whether they were right-handed, use of public transport, height, competed in a fun run, and number of siblings in their family. And then we've got all the results here. Participants were allocated an ID number so that we didn't know who they were. All right, and then we got started on the sack. So that's all the data we need to look at for now. All right, a set of data is one column of data from the table. So we've got eye color is one set, gender is another set, age is another set, and so on. Selecting one set of data, organize the data in a frequency table. So you could choose anything you like. You could choose, probably wouldn't choose ID because they're all different, so it would be a bit silly doing that. Eye color you could do, gender you could do, age you'd have to put them into probably intervals. Right-handed you could do, use of public transport you could do, height again you would have to put them in intervals, fun run you could do, and number of siblings you could do. So I can't give you all the different answers because it would be here forever. But this example here, we've got right-handed, yes or no, and then their frequency. Just reading what it says on the side. Any data other than ID could be used. Height and age would be poor choice, maybe. Don't know. Yeah, I think it says poor choice. So if I was choosing the data, there's no eye color. You've got a few more options there. Then right-handed, yes or left or right. Gender, male, female. We don't have any O's or P's. Yeah, so just think about what you could display in a frequency table. Then selecting another set of data. Oh, sorry, it doesn't say another set, one set of data. So you could represent the same one, represent it in a dot plot. So for this one, we've got number of siblings, 0, 1, 2, 3, or 4. And you could choose anything that's listed there as well. Now, it says to do it as a dot plot, bar chart, probably the most common. Select a different set of data, represent the data in a percentage segmented bar chart. If necessary, round percentages to the nearest whole percent. So again, choosing whatever data you like. So for this one, what was it? Was it male? No, right-handed again. So a percentage percentage segmented bar chart, you need to obviously work out the percentages. So we've got right-handed, yes or no. You could also have hand preference, left or right, but just making sure you've got a key there. So to work out your percentages, what's done up here. So just 16 over 20 multiplied by 100. So if I just go into my calculator, so 16 over 20, because there were 20 people, times 100, and that gives you your 80%, and then obviously 20% is the other. All right, and I can see there now it says yes or no for right-handed. You could also just have left or right because that's what the variable is. Where are we? Oh, right-handed, yes or no, sorry. I thought I saw left and right, yes or no. Okay, cool. All right, moving along. Select one set of data, represent in a... Sorry, the dog's barking at the possums. Select one set of data, represent the data in a histogram. I actually wouldn't represent, I don't even know what that's representing. So histogram should be for intervals. Probably don't know what that is representing. Probably number of siblings. So you should really, I would say, choose height or age. So you're putting them in interval data. With number of siblings, you can't really put them into an interval. That's why it's like that. So if you did age or height, probably better. You can do histograms on your calculator quite easily. So just to quickly remind you how to do that. So keyboard, oh gosh, where am I going? Menu, statistics. Well, look, got some values in there already. I'll just quickly do it for this one. So we just go to histogram, and I've already labeled mine XY. If you've still got a list and so forth, just make sure you put the right one in there. And then we go here to see it. Here it asks you where to start. So I'll just start at 150 and maybe make the intervals 5. And you can see there's the histogram. If I go to analysis and trace, see my little cursor up here. This part down the bottom just tells me where I start. So 150, so it'd be 150 to 155 has a frequency of 3. So it can help you sort your data if you wanted to. So this one here is, so this part is where it starts, 155 to 160. So remember I told it to do a width of 5. So it has a frequency of 1. Here we're going from 160 to 165 has a frequency of 4, and so on. So you can do it in your calculator as opposed to doing it all by hand. All right, and then a stem plot. So for a stem plot, you really need to pick data that is more than 1 digit. So you can't do number of siblings because it's a single digit. You wouldn't do ID because ID doesn't really tell you much at all. It's just a number, and you've got all different numbers there anyway. So you can do age or you can do height, would probably be the only two you could do on a stem plot. So for this one, looks like it's age. So we've got on our stem our tens column, so we can see here the interpretation of it. And then on our leaf is the ones, so 20, 25, and so on. All right, then we're going to do a box plot. So for a box plot, you do need numerical data. So you could use, as it says over here, age, height, or number of siblings. It's a little bit hard to see, the orange box plot there, but it is of age. So you can also do that on your calculator, which I'd probably encourage you to do so. So I'm just going to use the same data, but this time we choose box plot, med box, and make sure you just click show outliers, and then click here to see it again. All right, so remember I've just got some random data that was in here for some other question I was doing. All right, and again, you can go analysis trace and move your little cursor along. All right, so we've got the minimum, it says down here, your Q1, your median, your Q3, and your max. If you have outliers, that's your maximum. So there's no outliers for this one, but if we had an outlier, that would be your maximum value. All right, represent the data for gender and right-handed in a two-way frequency table. So with the data, you would have to look at who was male and whether they were right-handed or not, female and right-handed or not. So completing that, you'd probably have to do a tally as you went along or just count them, but it's a bit hard because you're looking at two variables. All right, write down the number of categorical variables in table 1. I wonder if they're listed there, so I don't have to, no. All right, so let's have a look at them. So ID is a category. It just identifies who you are, even though it's a number. Eye color is a categorical. Gender is categorical. Right-handed. Use of public transport and fun run. So is that 6? 1, 2, 3, 4, 5, 6. Awesome. So just remembering ID is categorical. All right, write down the variable which is an example of, I hate it when this flashes at 10 minutes, I don't know why it flashes, is an example of a numerical continuous variable. So basically anything that can be measured. So height in centimeters. We're also measuring age in years. I know that they're in whole years, but age is a difficult one because, you know, I'm 43 in July, so I am still 42, but I am 42 and 10 months, 11 months, so yeah. So your height, I'm probably around 178 centimeters, but I could be 178.2 centimeters. So there is an argument that age could also be continuous because it is it's measured in years. All right, determine the median age of this sample. So easy, just adding them all up and dividing it by 20. Determine the standard deviation for age. So when you do the mean, you can also do the standard deviation. So you can do it on the main screen, but because you have to do the standard deviation as well, you may as well just do it on your spreadsheet. So just calc one variable. I'm in list X, and so X bar is your mean, and then SX is your standard deviation. Remember, different data, so that's why we're not getting the same values there. All right, determine the mean number of siblings for this sample of people. So if we don't have to do anything with that, you can probably just type it into, actually I would just put it into a list, to be honest, and let the calculator do it, because you know, if you make one error, and it's a lot of numbers to type in on your main screen, so I would just put it in a list and do it that way. You might also see if there's lots of 2s, it's probably going to be, yeah, anyway. I was just going to say, if there's lots of 2s and that's your median, then your mean's also going to be 2. Like if it's symmetrical data, then your mean and your median are the same. Determine the percentage of people who have a height greater than 165 centimeters for this sample. So we go back, go to our height, count up how many there are. Obviously there's 9. So 9 over 20 times 100 gives you 45%. Write down the mode for eye color. So that's the most popular eye color, blue. All right, determine the percentage of people who use public transport regularly or on weekends only. So we go back, use of transport. So what were the two? Regularly or weekends. So I would say R and W. Makes sense. If you forget, it says up here. So regularly is R and weekends W. All right. Justify by quoting appropriate statistics why the data for the number of siblings for this sample of people has a symmetrical distribution. So this is what I was saying before. So if your mean and your standard deviation are the same, then your data set's pretty much symmetrical. So yeah, when your mean and your median are equal, your data set's symmetrical. If your data is skewed, then your mean is going to be skewed. So just remember the age of people in our classroom. If we were just doing you guys, it's probably going to be around 17. If you add me into the mix, I just told you that I'm 42, I would really increase that mean. So that means the median would be a better measure of center. So when you've got skewed data, the median is better. But when it's symmetrical, the mean and the median are pretty much the same. So both are pretty good. All right, calculated the standardized Z-score for the age of the person with an ID number of 12. So you just go here, find that person. So here, this is person 12. There's all the data. You can see, can't really highlight it too well. So what are we doing for the age? So that person is 25. Oh, I could have read it from here. And then we've got the mean over the standard deviation. So we needed to, did we calculate that mean as, all right, we did the mean age, oh no, we did the median age and the standard deviation. I think I didn't read that question properly before. I think I read it as mean. All right, the median age, let's go back. So then the mean age is 40.8. So you'd have to calculate it on your calculator, which you probably did when you did the standard deviation. That's why when you're doing, when you've got reading time, it's probably a good idea to think, okay, what do I need to actually do on the spreadsheet as opposed to just on the main screen of the calculator. All right, so we get negative 1.1 to 2 decimal places. We're going to put the 0 on the end, so negative 1.10. So that means they're below average for the age. So the average is 40.8. We know they're below because 25 is below 40.8, but just about 1 standard deviation below the mean. All right, of the females in this sample who have blue eyes, determine the percentage who have 2 siblings. So we're only looking at those who have blue eyes, so we'd probably highlight them and then see how many of them have 2 siblings. All right, and then of the males in the sample, determine the percentage who are right-handed, so you do the same thing. So that must mean only 4 are blue. Is that right? 1, 2, 3, 4, 5, 6, 7, maybe there's 8. Okay, so maybe 2 out of 8, I would say. All right, oh, and that's the end. So pretty straightforward SAC last year. So just make sure you know the main calculations and also how to put data. The video I finished in 17 minutes, but remember putting that data into your calculator will take time. So just making sure that you don't make any errors when you do that. And obviously drawing the graphs does take time as well. So if there's a lot of drawing, you could start with the questions that don't require you to draw. So like for example, this one here, you could start at question 2, get all these questions done that didn't require you to look at your graphs and then draw the graphs. So you're not spending so much time, drawing your graphs. You're probably managing your time a little bit better. All right, guys, see you later.